Our next speaker is Brian Ulciny, who is a founding member of Thomson Reuters Labs, which is in Boston and in many cities around the world. It develops data-driven solutions across a variety of disciplines. He earned a PhD from MIT in linguistics and philosophy.
Great, thank you very much. Thanks for inviting me. Oops, here we go. Okay, so yeah, I'm just going to tell you a bit about Thomson Reuters and the sorts of things we work on, and hopefully get you excited about what we do and inform you about what we do, and maybe invite your collaboration on some of these problems. So yeah, I graduated from Course 24 in linguistics and philosophy, and so I was a semanticist by training and became a computational linguist, now turned data scientist. And when I was at MIT, I certainly didn't know anything about Thomson Reuters, and so let me tell you a little bit about what we do. So Thomson Reuters has been a very old company. We've been around over 150 years. So we started off as a news agency, the Reuters news agency, as you know, and we still have reporters all over the world. But we gradually moved from reporting the news to providing information and data to professionals in finance, legal information about court cases and decisions and citations between cases. Tax, we have a big unit that provides tax information, lots of information about risk and compliance. And so these are very highly curated data sets that we manage and maintain and distribute to professionals, and they use them to make important decisions in their professional lives. In 2014, the Thomson Reuters realized, look, we've got all of this data that we've acquired over the years, primarily through acquisition. They acquired various data providers across different spectra of industries and so on, and largely these various information sources were siloed within Thomson Reuters. But this whole big data technology stack was happening, and so we realized we could ingest all of this stuff into common repositories. And in the meantime, we had undergone this merger between the Thomson, the legal part of the business that sells things like Westlaw, that if you had gone to law school you would know about, and Reuters, the financial and news part of the organization. So we'd built this data model that allowed that sort of represented how all of these pieces of information fit together in the abstract, but in this big data technology world, it was now possible to join all this data together in practice, and then build all sorts of new predictive models on the basis of this joined up data across different areas of industry and so on. And so we started here in Boston. We were the first of the data labs that Thomson Reuters has started. So we're about 10 data scientists, including people with backgrounds in quantitative finance and physics, and people with law degrees and machine learning experts and NLP types. And then the lab model was expanded to Waterloo, Ontario, London, Zurich, Cape Town, South Africa, and Singapore, which we just launched in February. So the idea here is that with all of the labs, we work with internal customers and external customers to do new things with all of this data that we have, and rapidly develop proofs of concepts on new sorts of data science products, either predictive analytics, even data visualizations that help people make sense of the data and do things with it in their professional lives. All right, so this graph just shows some of the various kinds of data sets we have and how they're connected. One thing that we're investigating, one project that we've been working on as a organization is taking all of this data that we have gathered over the years and constructing a giant knowledge graph out of it. So these show the sorts of things that we're connecting. So we're very much, organizations and companies and their officers and directors, for example, are very important to financial professionals in the instruments that they trade and their pricing and fundamental, statistics about those companies and court cases that they're involved in and dockets that those cases belong to and news about the companies and so on. These are all being ingested and formed into this gigantic knowledge graph with billions and billions of nodes and edges, and we're trying to see how this graph-based representation of all of this professional knowledge can be used to do interesting new things. These are color-coded by the sorts of industry that or the business unit that they belong to. And while I'm here, I'd also like to make people aware, since this is a data science group, we provide a lot of data for free to the community that we would very much encourage people to use. So at a site called permid.org, we provide firmographic data. I just learned that term and I really like it. Firmographic data about 3.5 million companies, both public and private. So where they're domiciled, their industry, officers and directors, if those are public, market cap, all sorts of fundamental data for 3.5 million companies worldwide, which is very useful then for doing the kinds of analytic work. It also links up to public identifiers. So if you want to know their SEC identifier, their CIK code, that's part of the data set and so on. So it's very useful, and we encourage you to go and download it. And we also make public a named entity tagger and topic model tagger called Open Calais, or at least it used to be branded Open Calais. Now it's called Thomson Reuters Intelligent Tagging. And there's an API, and you can run unstructured data through this API, and it'll identify companies and persons, and if those companies are part of the data set of 3.5 million companies where we have an identifier assigned to that, it'll say, this company has this particular identifier, and do that kind of disambiguation for you, so you don't have to write rules that say Microsoft Corp and Microsoft Corporation and MSFT are the same thing, and so on. We'll do all that work for you. So I would encourage you to go and look at that. So finally, I'm just going to talk a little bit about some of the projects that we've done in the lab with MIT students and that we're planning to do in the near future. So within Thomson Reuters and the labs, there's a lot of use of statistics and machine learning to both prepare this information for curation and ingestion. So there's a lot of use of statistical natural language processing to do things like identify entities within text and disambiguate and concord entities. So say, that this piece of text, Michael Jordan, denotes the basketball player, whereas this other piece of text, Michael Jordan, denotes the machine learning expert, and so on. So all of that is bound up with machine learning and so on. We also make do lots of predictive modeling for, say, estimating, for doing smart estimates about earnings and so on, credit ratings from text and so on, things like that. So all sorts of predictive models. We had undergrad interns for the month of January that joined us, and they participated in a federally sponsored challenge it was a challenge issued by the Office of Financial Research, And the OFR was started after the 2008 financial crisis, in part to sort of figure out or to address this problem that when the 2008 crisis in the financial system happened, really no one had a sense of who had lent what to whom, who were all the counterparties, how these financial networks were actually laid out. And so the OFR has started these challenges to encourage people to develop techniques for mining this kind of information from text. So in the challenge that the undergrads participated in, they worked with people in the lab to identify certain relations within public filings, things like this entity is the guarantor of a loan to this other entity, things like that, with using the NLP techniques and graph-based techniques and so on. And I'm happy to say that the undergrads and the lab came out tops in at least one category and a close second in the other categories. So we were quite pleased. And just to go back to, for another example, one of the elements of the knowledge graph that we were constructing is supply chain relations. So understanding the global supply chain is something that would be really important, but for the most part, not everyone publishes their supply chain information. The supply chain information can be very proprietary, very valuable. So we have gone through and mined at least two sources of information where suppliers-customer relationships are made public. So sometimes people do divulge in their public filings or within news or press releases that they are supplying another customer. So we mine all of that text, and we've identified hundreds of thousands of these relationships in text, and then use statistical techniques to validate those entries. And one of the things that we're looking to do in the summer with a student of Devavrat's is to use things like matrix completion techniques to see if we can infer supply chain relationships that haven't been made public, or if we can use matrix completion techniques to identify or to provide additional support to supplier-customer relations that we maybe have found in text, but we didn't have enough confidence in to include in the published data set. And then being able to flesh out our supply chain information this way is quite valuable for doing things like predicting resilience of supply chains and identifying, if having a more complete picture of the supply chain will help us do things for our customers, like say if there's an earthquake in Japan, which companies are going to be that aren't based in Japan are likely to be affected by that. So these are very interesting real-world applications that have great utility and value to our customers, and that the work that is being done at IDSS is very helpful in exploring. So I think I'll end there and just see if there are any quick questions I can answer.
A quick question about the earnings estimates. So these are acquired from other financial firms, or you actually make these earnings estimates? How do you get your data on earnings estimates?
Right. So we do something called smart estimates. So we take analyst estimates of earnings, and then we try to find the best. Make the best prediction on the basis of those, where we can outperform just taking the average or so on by looking at past performance and so on.
Okay.
Can you talk a little bit about the coverage of your data? In particular, is it just US-centric, or is it international, and is it just a public company focused, or do you have private companies as well?
Oh yeah, no, that's a great question. No, it's global. So we have we have people all over the world where we've been in 100 countries, over 100 countries for over 100 years. We cover all of the stock exchanges in the world, not just the major ones. So we have a product, for example, called Investor Briefs that for any sort of material change in a company that they put out in a press release or something, for the major exchanges, the US, the UK, and so on, we summarize that release and put it on the wire in something like, I think we guarantee less than 2 minutes. And for the rest, worst case, for some obscure exchange in the world, within something like 2 days. So we cover everything in the world. We have reporters all over the world. We cover public and private companies. Perhaps the legal data in the Westlaw sorts of things, those are more, I think that coverage is essentially mostly US, UK, Canada. I might be getting myself in trouble there, but for sure that's the major emphasis.
Thank you very much, Brian.